Well, hello everyone. This is KP the Math G here, sporting off my new jacket that I got about 2 or 3 days ago. My wife found it for me, and it was on sale, and I got a good deal off of it. And yes, it is a pretty nice jacket. You know, I always wanted a kind of a jacket that those football players get, that when they a letterman's jacket. That's what I'm thinking about. So I just got my own. Hey, 64 years old, I got my own letterman's jacket, and no, I didn't play polo, but that's all right. Looks good. So I just thought I would sport it out. It doesn't match anything to this shirt here, but it's all right. It's all good. We're just here to look at a calculus problem. We don't care what I look like, right? So anyway, let's see if we can move this over here just a little bit and see if I can adjust this camera over a little more. Hey, that's about it right there. Alright, let's get started. I am KP the Math G. Again, the G could stand for not genius for sure. But some people might call me the guru, I don't know, but anyway, or just plain G, it doesn't matter. We're looking at the 2022 free response question number 4. And T is in days, R prime at T is given by centimeters per day, and this is the table that we're looking at. So it talks about an ice sculpture. It melts. And it's modeled as a cone that maintains its conical shape as it decreases in size. The base radius is twice differential. R is twice differential. Alright, so R at T is measured in centimeters. T in time T is measured in time over the interval. T is between and including 0 and 12. So there it is right here, from 0 to 12. Alright, so let's talk a little bit about this. This is going to be, we're going to look at parts A and B is what we're going to do. And then my next video, I'm excited about this one. I'm kind of really excited about parts C and D, but you do need to see both of these parts. Actually, every one of you at this point should be able to do part A by now, okay? If not, I'll show you how to do part A. If you're still stuck, hey, I don't understand this, well, I'm going to show you how to do part A. And then I'm going to show you how to do part B. And bear in mind, we are dealing with something in between two numbers, okay? So let's take a look at this problem here. All right, we're just going to have to flip back and forth. My board is just not big enough, so we're just going to have to go back and forth here. Here we go. Let's look at the question. This says approximate R double prime. Alright, so that is the rate of change of the rate of change. Alright, 8.5 using the rate of change of R prime over the interval, and T is between 7 and 10. Keep that in mind, that time is between 7 days and 10 days. Including those, and so that's what you have to do. So what we gotta figure out over here is that, okay, so R double prime of 8.5, okay, is about equal to R prime at 10, and keep in mind you do minus R prime at, this is what rate of change means here. And then of course you're going to subtract off 10 minus 7. So let's put in these values here. R prime at 10 is negative 3.8. So there we go, negative 3.8, negative 3.8. Minus sign, don't forget that. Alright, and then over here, 7 is going to be negative 4.4. Okay, here we go. So negative 4.4. And we might as well just put 10 minus 7 is 3 right here. And then this is equal to, let's see, minus a negative is a plus. So let's just do that. Alright. And then 14 minus 8 is 6. That's a decimal there. And then when you take one off, you subtract and get that. And that's going to be a positive 6 over 3, which is 0.2. Now 0.2. Now can't just leave it like that. We got to be able to interpret what this R double prime stands for. Keep in mind that R prime is equal to let's see, what is that? Centimeters per day. Alright, so R double prime is, oops, sorry. That's going to be centimeters per day, which is centimeters per day squared. And you have to have that, otherwise you do not get all the credit for that problem. Okay, that's it. And again, I say that you have to be able to do this by now. This is one of the easier type problems. The key to understanding it is really looking at this interval right here. Okay, so R prime at 10 minus R prime at 7 over 10 minus 7. Always a minus between those. Okay, and so that's what we're talking about here. Simply plug the numbers in place of these and then figure it out. Centimeters per day squared. Okay, so that's what that is referring to here. All right. So let's look at now. Let's look at B. And since I didn't have space to write B, I'm gonna need all of this space anyway. So let me erase all of this. Sorry about that. Taking up so much time. I do appreciate everyone tuning in here, who does tune in, who's still trying to do something with this test. I'm sure it's coming up very, very soon. So let's look at part B. We'll put this in a different color. Okay, part B. Now, I like this problem. I like the other one. That's pretty good. Let's put this right here. Is there a time t? Bear with me. I apologize. Is there a time t? Okay, a time t. All right. On this interval. On the interval. It's a closed interval. All right. Let's look at this here. Interval. Okay, t is between, including, some people may write this as 0, 3, like that. That's okay. Okay. For which what is it? R prime at t is equal to -6. All right. Now, the idea behind this problem here is testing your ability to determine, this is going to be, is there a time t in which then anytime you see that, all right, Sometimes you're looking for the mean value theorem, but in this particular case, we're looking at the intermediate value theorem. And then, of course, there is the extreme value theorem. And so maybe what I'll do is do a lesson where we're doing all three of these, and so we can get a good understanding. If you want to put that in your comment section, please do so, and I will be glad to do a lesson on that. I do, out of 152, this is going on 153 right here. Out of 152, I do have something on both, the other two, MVT and also extreme value theorem. So anyway, now without getting into those in detail, let's talk about this. This is definitely an IVT type question. All right, is there a time t on which on this interval for which r prime at t is equal to -6? Well, now what we got to do is we need to know what r prime at 3 is equal to. Well, first of all, let's look at our problem. I'm getting ahead of myself. Bear with me just a moment. Let's look at something. Now, here's another thing you got to remember. If there's a time t, you have to, they're honing in on this very thing right here. Now, look at this. Let's look at this again. It says right here, the base radius, or the radius of the base, is twice differential. Twice differential. All right, is a twice differential function of r prime at t, so on as centimeters, t is in time. Okay, over this interval here. Okay, so anyway, twice differentiable. When you see the phrase twice differentiable, so when you see that, most of the time you may be looking at IVT, twice differentiable. What do you know about a function where this is twice differentiable? Well, you know about it. In this case, we're talking about the rate of change of the radius, right? Okay, so that means, okay, you know, right? Yeah, that means that it's continuous, right? So you must say something like this. This is what I said, and I'm going to put it in the order that I've got. You got to say something about continuity. Otherwise, IVT is out of the question. Okay, there's a number in between because it is continuous. There is a number somewhere in there, okay, such that r prime at t equals -6, right? So that's what we're looking for. Now, first of all, because I just like to say B/C, because, and any reader will know that that means because. All right, because the function, all right, the function r is twice, I'm just going to abbreviate this, differentiable, okay, then r prime is also differentiable, okay, and therefore, hence, therefore, wherefore, what do you know? What do you know about r prime? If it's differentiable, what do you know? Oh, it's continuous. Therefore, r prime, r prime is continuous. Alright, that's on any interval from 0 to 12, right? But we're looking at from 0 to 3, so on the interval, alright, you can do that on that interval. It's continuous. Now, you've got to have that, otherwise, forget, they're not going to even look at anything else. Just point blank. If you put down somewhere IVT, you might get a point for that, but you do need to say why it's IVT. All right, you have to somewhere get into this word right here. And the key again, twice differentiable. Okay, R is twice differentiable, means that R prime is also differentiable, and therefore R prime is continuous on this interval. Now, part 1, that's it, right? Part 2 of this is we need to find R prime, so R prime at 3 equals what? And then we got to also say R prime at what? Oh, well, 0. Let's do 0 first. I don't care. 0. And R prime at 3 is, alright. So let's go back to our table. R prime at 0. R prime at 0 is negative 6.1. R prime at 3 is negative 5.0. Okay. Negative 6.1. Oops. Come on. Oh, don't hit me in the head. Negative 6.1, right? Negative 6.1. Okay. R prime at 3 is, let's scoot it over a little bit so we can have a little room. R prime at 3 is negative 5.0. Question, is negative 6 between negative 6.1 and negative 5.0? It absolutely is. Okay? Now, so we say then, another because, let's see, negative 6.1 is less than or equal to negative 6 is less than or equal to negative 5.0, then, not them, then by what? What's the reason? What's the theorem? Alright, my IVT. You better say that. That's your point. That's a point right there. In IVT, what? There is, okay, there is, there is what? A time on the interval. We're just going to abbreviate this. We're just going to say 0 to 3, right? Yeah, 0 to 3. Negative. Time's not negative. All right. Time on, there is a time on this interval such that, or for which, or such that, watch this, I'm going to show you such that, you can do that. Look at that, such that, or for which, let's just say for which. Alright, for which what? For which R prime at t is equal to negative 6. Somewhere on this interval. Now it's got to be continuous. So what gives that away? It's twice differentiable. If it's twice differentiable, not only is R differentiable, but R prime is also differentiable. And if r prime is different, then r prime is continuous on this interval. As we are looking at r prime, aren't we? Yeah. So r prime at 0 is negative 6.1. R prime at 3 is negative 5.0. So because of that, all right, then by IVT, there is a time on this interval, this closed interval, for which r prime at t is equal to negative 6. There we go. Period. I love this problem, and I do believe that if you need anything, you probably need a little IVT problem somewhere in here. But pay attention to the words when you start off. You might be looking at IVT because they say twice differentiable. You say, oh, continuous. And remember, continuous does not necessarily mean differentiable. But here when we see differentiable is automatically what? Continuous. Keep that in mind, okay? Keep that in mind. Oh, we might be looking at IVT. Yeah, in this case, we are. Is there a function? Is there a time t on which the interval, okay, on the interval for which r prime at t is equal to negative 6. Anytime you see that, IVT. Okay? Alright. Alright, so, anyway. And I hope maybe that first problem, again, that should be something you should be able to do fairly easily. And let's see, again, the first problem was on the interval from, I want to say from, was it from 7 to 10? Yeah, from 7 to 10 right here, using these two. Okay, this minus this, or you can go here, this minus this over this minus, but you can't go this minus this over this minus this. You got to go left, right, left, right. And time is on your denominator. Okay, all right. R prime is going to be in your numerator, so you can get r double prime. Okay, that's what you're really wanting to get. Okay, so that's what you have to do. All right, had it been something from 3 to 10, you would have used this. Okay, 10 to 12, you would have had to use this. Okay, so rate of change is what it is. Okay, all right. So anyway, there's that problem there, and these are really nice problems. These are probably nice review problems that you can take with you and use when you're doing this. Again, I'm going to try to get some more problems out there in a more, not putting so much lapse of time between problems, but start putting them together more frequently. I'm not saying every day, but almost every day we'll have more of those. So please hang in there with me. I'm just trying to, we got a lot going on around our house right now, but bear with me. We're getting things done. So this is KP, the Math G, getting ready to sign off. Appreciate everyone. If you would like to subscribe, please hit that subscribe button. I appreciate that if you would. If you would like to hit that like button, please do so. Well, I always smile when I say that, don't I? But anyway, whatever. I do like the like button. If you'd like to make a comment, please do so. I appreciate that, and I do appreciate you very much. This is for you. I'm not making any money off of this, but I'm doing this for you. This is for you, and not so much for me. It does keep my 64-year-old mind sharp. So I do enjoy doing this. I really do. I wish I could be teaching just calculus, AP calculus, AB, all day long. So if I had to go back to teaching, that's what I would do. Even a half a day would do for me. I love that. So anyway, this is KP the Math G signing off. Ladies and gentlemen, have a great day.